All right, greetings YouTube. This is Beautiful Mind. This question comes from Beautiful Mind Jenn on calculus and taking it to the limit. So we have this discussion on limit. Let's take a look at it. Okay. So this says to complete the table, round your answer to 4 decimal places, and then this. So now this is all I had as far as the picture is concerned. So I'm under the impression that my f of x is 1 over x plus 1, right? And then we want to evaluate the limit, so we're taking the limit as x approaches 5 of f of x, right? So we want to evaluate this limit as x approaches 5. Now, I'm under the impression there are 2 trains of thought here. So we have this reciprocal function, like I guess we can do a quick, I'll just do a quick graph here. So the original function, if I go to here, probably should have kept that, but that's okay. If I do 1 divided by x plus 1, right? 1 is 5. I'm just going to do a standard zoom. So we get a reciprocal function. We got a vertical asymptote at -1, all of this jazz. Now, as x approaches 5, 5 is going to be way over to the right somewhere. So I'm going to go to my calculate. I'm going to hit second and then F4 or trace and number 1. So now when I plug in 5 here, we get this 0.6. So you plug in 5. So now when x is 5, the y, which is our f of x, is going to be 1 over 6, which is 0.16 bar. So that's like your x comma y. So you have your 5 comma 1 by 6. Now, that's when x is 5, the value of the function is going to be 1/6. Now, when we're doing discussion, now if I could zoom, let me try to do a zoom box. Number 1. I want to zoom around this 5 and try to blow it up some so you can see what's going on. All right, let me hit enter. Just do a zoom box. So now when we're now you can't really see it here but you see it's not a straight line. There's an actual slope to it. So this whole discussion around the limit at a point is really a discussion around the slope of a tangent line. And what do I mean by that? So as a quick sketch, just to get for concept wise, so I'm just going to try to kind of be close to what's going on here. So now say we had a curve like this, right? And say that here's our 5 here. When x is 5, and it gives us this. And we want to look at the slope of the tangent line through that point. Now, if you want the slope of a line, you typically need 2 points in order to talk about slope. You got to have a rise or the run. You got to have a 1 point and a second point to compare it to. But if we're looking at a point, it's not so obvious to talk about slope at a point. And, I know my curve is not the best. Let me see if I can do a better curve. So say it was like coming like that. Something like that. It's the curve. So we're talking about slope at a point. And then I could do this actually. Bam. That's good enough. Okay. So to talk about slope at a point, you typically would need a second point. So we have 2 ways of doing this. Now, in calculus, there's one. So you have this first when x is 5, and then we're going to consider a second point. Now, now just put it off to the side for right now. So we'll consider a second point. Say when x was 6. Now, if x was 6, we might be here. We can connect those 2 points with a straight line, and then, we can find the slope between those 2 points. So then let's say x was 5.5, or let's do 5.9. Still close, still not 5. You can find the slope between those 2 points. Then if x were, let's say 5.1, and then 5.01, and then 5.001. So as this point gets closer and closer to our point in question, every time we find the slope between those 2 points, we get the slope between 2 points, that a line that crosses a curve more than once, we call that a secant line. So as we find the slope of the secant line between these 2 points, as this second point gets closer and closer and closer to our point in question, then that slope of the secant line is going to be a better and better approximation for the slope at the point. See what I'm saying? So one technique is that we could do If we want the limit as x approaches 5, now this might be a little off, but we could say f of b minus f of a over b minus a, where your a is 5. Okay, and so we can do something like, yeah, just as x. I'll leave it as x approaches 5. So if a is 5 and then b is just going to be changing, so b is going to get closer and closer to 5. So then that's where this table comes in, you know, and so that's how we get the b when x is 5, right? We get the 1 over 6, x minus 5. So that's where this table comes in. So as x changes and gets closer and closer to 5, then we get a better approximation of the slope of the tangent line at the point by taking the slope of the secant. So when we fill in the table, okay, so let me show you how to quickly fill in the table. So then I'm going to go to y equals, right? I'm going to just suppress this. I'm going to let that stay. And I drew my curve like this because we actually do get a negative slope. So let me kind of go ahead and put in what we have going on here. So then we could say, I'm just going to put in what you see here on the left. So now I'm going to do open parentheses. This is for my numerator. Now I'm going to start that first box. Then I'm going to say 1 divided by, I'm going to open up the second set of parentheses, x plus 1. I'm going to close the second set of that inner parentheses, and I'm going to close that square bracket. So there's still there's a third parentheses off to the far left, but that's going to capture my whole numerator. Now I'm going to say minus. I'm just following basically what's here. Okay. So then I'm saying parentheses 1 divided by 6, close parentheses. Now when I want to close off that whole numerator, now I'm ready to close the numerator because I did an extra parentheses in the beginning. I'm going to say divided by, open parentheses. Now I want to do the entire bottom, x minus 5, close parentheses. Okay. So now I feel good about this. I suppressed my other one, so now the only one that's operational is the second. So now there are a couple of ways to quickly find these numbers. I'm just going to choose my favorite way where I saw somebody else do it on YouTube. I can't remember who it was, but I saw someone else do it. I got the idea from them. I enjoy it. So I'm going to go to quit. I'm going to clear my home screen. Now to quickly plug these in, I'm going to go to variables. If you look at clear on the far right, the button to the left says variables. I'm going to click on that. I'm going to go to the right where it says y variables. I'm going to go to my function. And I'm going to call on y2 because I put this function into my second slot. Okay, so this is just like saying f of x. So I have y2 of, I want when x is 4.9. So I'm going to plug in 4.9. I could close the parentheses, but for speed, I'm not going to. And I get this, right? So, yeah, we can put it here. So when x is 4.9, then my f of x is negative 0.0282. All right, let's keep going. Now when x is 4.9, so now this is like saying f of 4.99. When I plug that in, I get negative 0.0278. 0278. Okay, let's go on to the next one. I'm hitting second enter to recall the previous thing I put in. I'm going to put 4.99. Enter. Negative 0.0278. 0278. Same thing. That's fine because this is an approximation to 4 decimals. So next, I'm going to call in my function. Now I'm doing a whole nother number. It's 5.001. And I get negative 0.0278. 0278. All right. Then I'm going to just call it back again. I'm going to remove a 0 because I want to do 5.01. Negative 0.0277. 0277. And then when I do 5.1, so we're just going to remove another 0. And this is all for a TI 83 plus. Okay. Negative 0.0273. Okay. So I showed, come on, acting up on me. There we go. All right. So we saw how to generate this table quickly in a calculator. You go to your y equals, you put your function in, and then again, right to the left of the button, clear button, you hit the variables. Again, you hit variables. To the right, you go to y variables. The first one, I put mine in y2. So Because when I did y up here, I did mine in y too. So then you do that and you do this. Okay, so we generated this table. So what this means is as that second point gets closer and closer to the point in question when x is 5, we notice that the numbers, look at this. So we notice, back up, undo. So we notice as our x gets closer and closer to 5 on the left and the right, notice these decimals, they get closer and closer to the same decimal, 0.0278, 0278, 02, because of rounding, 0278. So as we get closer and closer to the point in question from the left and the right, it approaches the same thing. So the left-hand limit equals the right-hand limit, so then we say that the limit exists.